Hey kids, Mr. Murray here, Mr. Murray's Mathland channel, and we're talking today about determining the relative extrema, maxes and mins, that is, for a function, as well as describing the intervals where the function is increasing or decreasing. Okay, so we've got a nice polynomial function here, and what we want to do, regardless of the function, is determine its critical points. So that would be where its derivative is equal to 0 or undefined. So we get f prime of x equals negative 3x squared plus 6x. Negative 5 drops out. And this, of course, is a polynomial, so it's never undefined. But we want to determine where is it equal to 0, because we're going to find those spots where it's got a horizontal tangent line, because everywhere else its derivative will be positive or negative, and therefore it will be increasing or decreasing. So let's solve this equation right now. Where does this function equal 0? We're going to do a little bit of factoring here. We can take out negative 3x as our greatest common factor, and then x minus 2 equal to 0. Set each equal to 0. We get x equals 0 and x equals positive 2. Okay, so two critical points. So two potential relative maxes and mins, and let's determine which is which. And while we're at it, determining the intervals of increasing and or decreasing. So to sort of organize all this information, we use what's called a sign chart. You could make, it's really more of a number line the way we draw it on, but you could make more of an elaborate chart if you want. But this is a simple way to sort of organize a lot of data at once. So thinking of a number line, and 0 and 2, I'm going to put those on the number line, in order, of course. It is a number line. And I'm plugging into f prime. That's the key. I'm plugging into f prime because f prime is where I got these two values from, and these are the two places where I know f prime is equal to 0. Therefore, every other x value, f prime will either be positive or negative, meaning f will be increasing or decreasing. So I'm using f prime to tell me about f, and I actually like to label the top side of my number line as f to sort of mirror what's happening. So here's what I like to do. I'm going to plug in a value to the left of 0 into f prime. So if I plug in, say, negative 1, you can plug it into the expanded version or the factored version. Doesn't really matter. This is a fairly simple one. I usually like to go into the factored version, though, because I don't really need the value. I just need to know if it's positive or negative. So if you were to plug negative 1 into this, negative 3, well, the expanded one's pretty easy to plug into, actually. You'll get negative 3, but I'll still, to prove a point, I'll go into the factored one. Negative 3 times negative 1, and negative 1 minus 2 is negative 3, and I get a negative times negative is positive, times negative. This whole thing's going to be negative. In this case, it'll be negative 9. But the important thing is that it's negative, and that means every x value in this interval will yield a negative f prime value. So that means in this whole interval, whoops, there we go, f must be decreasing. So I like to draw a little thing just to visually show myself what f is doing to the left of 0. And in between 0 and 2, I'm going to plug in a value. Positive 1 is pretty easy. When I plug in positive 1, I'm going to get negative 3 times 1 minus 2. It's negative 1 on the inside of that factored quantity there, and I'm going to get a positive f prime value, which means f is increasing. So between 0 and 2, f is increasing, and when x is something greater than 2, so to the right of 2, maybe 3, when you plug in positive 3, you're going to get negative 3 times 3 minus 2 is positive 1, and so now you're going to get a negative value, and that's true for everything to the right of 2. So if f prime is negative, f is decreasing again. And so now that I've done this, let's take a look at what these two values are. For 0, f prime is changing from negative to positive, In other words, f is changing from decreasing to increasing, so I must be dealing with a relative minimum here. At 2, f is changing from positive to negative, meaning f is changing from increasing to decreasing, so we have a relative maximum. And so now I'm going to put all this together here. I've done all the work pretty much, but I do have to find those y coordinates for those relative extrema. Pretty easy to do though. At 0, f of 0 is going to be -5. So at 0, -5, I have a relative min. At 2, it's a little bit more work, but not much. F of 2, we're going to get -8 plus 3 times 2 squared. It's 4 times 3 plus 12 minus 5. So -8 plus 12 is 4 minus 5, -1. So at 2, -1, I have a relative max. And now for my increasing and decreasing intervals, the function is increasing the intervals 0 to 2 and decreasing over 2 different intervals from -infinity up to 0. That was that everything to the left of 0 and everything to the right of 2. So, and from 2 to infinity. And in case you're wondering, by the way, why I chose to use parentheses instead of brackets around these intervals, you know, to use the exclusive as opposed to the inclusive brackets, that is a kind of a debatable thing. I like to say that at 0 and at 2, you know, at these spots, it's not increasing and it's not decreasing. It's sort of changing. It's constant for that one split second. But it is perfectly acceptable to use brackets for those values. And some teachers, professors will choose to do so. The AP would accept either one, in case you're wondering. So that's just my take on it, my personal preference. It's just how my parents raised me, I guess. They said, son, always use exclusive in this situation. So I never forgot that. And if you want to check it out visually, you know, it's very easy to make a silly algebra mistake somewhere here. If you want to check it out, go to the graphing calculator, go to Desmos, something like that. There's my polynomial. Let's hit graph. There it is, that odd degree polynomial with the negative leading coefficient. And let's just turn on the trace and check these values. At 0, notice the y coordinate is -5. 0, -5, there's right on that relative minimum. And at x equals 2, 2, -1, there's that relative maximum. And you can see decreasing, then increasing, then decreasing. There we go. That pretty much seals the deal that we handled this. Okay, kids. So I've got a tougher example in video 2 that uses a quotient rule, just a little bit more complicated if you want to see that. But otherwise, you got any questions, let me know.